So yesterday we did vocab, and then at the very end, we drew a transversal on the back of our vocab, and we took patty paper, and we traced an angle, and we found all the angles that were congruent to that angle that we traced. Then we shaded and color-coded the angles according to which ones they were congruent to. Now we want to categorize all of our new vocab. Are they congruent or are they supplementary? So if we find two angles that are the same color, then that word goes in the congruent column. And if we find two angles that are different color, yellow, blue, then they are supplementary. Okay, let's start with it. So we're going to look at alternate exterior angles. So look at the picture and find a pair of alternate exterior angles. Alternate exterior, yeah, true. So it's here and here, right? Are those the same color or different colors? Same color. They are congruent. Cool. What about corresponding angles? Find two angles that are corresponding. Pretend that arrow is pointing to it. There you go. There and there, right? Same color or different colors? Same color. Corresponding, you go in the congruent category. All right, what about same side exterior? Blue and yellow. So those are not congruent. One's blue, one's yellow because they're same side exterior. That one goes in supplementary. All right, let's do, well, that one's old from last unit. What are vertical angles? Congruent, right? Old, new. What about same side interior? This one and this one. Oh, different colors. Huh, I'm noticing a pattern there. All right, what about alternate interior? This one and this one. Same color. And then old news, what about linear pair? Okay. So, moral of the story is if our lines are parallel, remember, we throw this out the window if these lines are not parallel. This is if and only if the lines are parallel. If and only if the lines are parallel, then same side interior and same side exterior angles are supplementary. Same side, supplementary. They all start with an S. Same side, supplementary, supplementary, same side. And this is old from last unit, so he doesn't follow the pattern. He's a rebel, but he has the word line in his name, and line and supplementary kind of go together. So anyway, all the other ones, there's no pattern. All the other ones, if it doesn't start with an S, they're congruent. Starts with an S, supplementary. Doesn't start with an S, congruent. Okay. Okay, so let's see if we can try these in an example. Let's start with the fact that the measure of angle 2 is 120. And let's use what we just learned, okay? Let's start by let's do one vocab word at a time. Find an angle that's corresponding to 120. What angle is corresponding? Angle 6, right? Not angle 4. It's hard because these are thick, like slats of wood. I tried to put a real world problem in there. So angle 6 and angle 2 are corresponding. I could do this for you. There we go. 2 and 6, those are corresponding angles. We know corresponding angles are congruent because it doesn't start with an S. So if angle 2 is 120, then angle 6 is 120. Okay, let's do another vocab word. 2 and 7. What are 2 and 7? What vocab word? Alternate exterior, right? That does not start with an S. If it doesn't start with an S, then they are congruent. So 7 is also 120. Let's do 2 and 8. 2 and 8. Vocab word. Same side exterior. Same side starts with an S. So 2 and 8 are supplementary. Same side supplementary. So what's the measure of angle 8? What's the supplement of 120? Good. Let's do 2 and, oh, we already did those. The rest of them can be solved with vertical angles and linear pair, pretty much. 2 and 1, those are a linear pair. So, supplementary. 2 and 3, those are vertical angles. Vertical angles are congruent. 2 and 4, linear pair. 2 and 5 do not have a vocab word. There is no vocab word for 2 and 5. So you could just use like 3 and 5 as an example. 3 and 5, same side interior. They're supplementary. The 5 is 6. Now what I want to show you is that, notice once again, all of these, there's only 2 numbers. There's only 2 numbers. So if all you're looking for are just the angle measures, there's actually a trick you can do. Let's say that this angle is 85. We know that vertical angles are congruent. We know that corresponding angles are congruent. Vertical angles are congruent. And now that I've labeled those, I'm just looking at this section right here. Now that I've labeled those, all the rest of them are the supplement of 85. 180 minus 85. So all the rest of them are 95. Now what's cool is that if our lines are parallel, it's going to follow the same pattern as the picture did, right here. You see how along a diagonal, everything is the same color? So what you can do is if you ever see a picture like this, with all of those crazy angles, you can pick one diagonal and you can just circle everything on the diagonal. You get circled, you get circled, you get circled. Keep going on that same diagonal. Now in these 16 angles, everything circled is 85. All of them done because of this. Everything not circled that I didn't touch is 95. So now I could call out any angle and you would know it right away. Angle 13. 95, right? Angle 10. 85. Angle 16. 95. Angle 11. 85. So everything circled or highlighted would be the same measure as long as you're going along a diagonal. If you stick to that same diagonal, then you can kind of use that trick to solve every problem in the example. Okay, now let's try some that are not as straightforward. I'm going to give you time to draw this figure in your notes and to actually solve for x and y. That's okay. All right, take a look at this picture. What you want to be on the lookout for is parallel lines in a transversal. Every picture, you want to take lemons and make lemonade. You want to take your picture and turn it into parallel lines in a transversal. So, I find the parallel lines, I can mark them. Sometimes I like to extend them, make them longer so that I can see what's going on. Now I need to pick a transversal. Okay, there's actually 2 transversals here. There's HI and there's GK. And I already know, because I already solved this problem, that GK is going to be the transversal we're going to need to focus on. If you looked at HI, then you can do that, but it kind of gives you a dead end. Some people even like to go to the side and draw their picture without all the crazy stuff in it. You see how you can kind of go to the side and get rid of the stuff you're not using at a time? So what's the vocab word for 122 and y? What's the vocab word? Corresponding. Corresponding angles. Yes, corresponding does not start with an S. Corresponding angles are congruent. Another reason corresponding angles are congruent, I just want you to visualize this when you're working a problem. This angle, because they have the same position, these angles can literally be subbed out for each other. They are literally the same angle, but just in a different position. So you can kind of always visualize that angle sliding across or sliding down to fit in the other one's spot. So y is 122 degrees because if lines are parallel, then corresponding angles are congruent. Okay, now we need to find x. And you have to remember that just because we're in the transversal unit doesn't mean we use transversals to find every single missing angle, okay? We can use stuff from the angles unit to help us solve. I see a straight line. I see 180 degrees. In those 180 degrees, I have used up 18 and I've used up 122. So I can add those up, the angles I've used, and I can subtract them from 180. So you can add them up and get, what, 140 and 180 minus 140. Cool? So no, you don't have to use our vocab to solve for each and every variable. Okay, next one. I want you to find x and y. Remember those arrows mean that those lines are parallel. The other two sides of this quadrilateral are not parallel. So you do have to be really careful here because our theorems only work when the lines are parallel. As a side note real quick, we did not take time in our notes to write down all of these postulates and theorems. I just want to let you know I'm referencing these, but they are already, oh, come on, you can focus. They're already typed out for you on this page that you got with lots and lots of words on it called Notes for Proofs. So all of the postulates are there, and that's why we didn't write them all in our notes. Corresponding angle theorem, alternate exterior angle theorem, same side interior angle theorem. They're there. I just wanted you to know that you have them because we didn't take class time to write them all out. Okay, so we're going to solve for x and y, and what I recommend is look at one set of parallel lines and one transversal at a time. Literally cover up the other two angles. Don't look at 115. Do not look at 74 minus y. If we're focusing on these two angles created by this transversal, what would the vocab word be for those two angles? Yes, same side interior angle. If two lines are parallel, then same side interior angles are supplementary. So you can just solve for x in your head, or you can actually write out the equation. 5x plus 40 equals 180. Subtract 40 from both sides. 5x equals 140. X is 28. Very good. Okay, now we're done with that side. Now we're going to focus on this side. Parallel lines, transversal. We are in the same situation. Same side interior angle. 115 plus 74 minus y equals 180. You might get a negative number. Negative y equals negative something. The negatives will cancel if that's how you end up solving it. 189 minus y equals 180. What I would do is just make these two trade places if it were me. I'd bring the 180 to the left and the y to the right. And you would get 9 equals 1. I want to give you a warning here, okay? I started this problem and you're like, yeah, I agree with you, I agree with you, I agree with you. But what some students are going to do when they get this problem, they are not going to pay attention and they are going to add these two to equal 180 and they will get it wrong. Why does it not work? Why are 5x and 115 not supplementary? Good. Because all of these theorems only work when you have parallel lines cut by a transversal. These lines, let's call it A and B, that's what the symbol of not parallel means. You put parallel and then a slash there. Those are not parallel. So don't you dare use the theorems on lines that are not parallel. Are they still called same side interior angles? Yes. But are they supplementary? No. we're going to try to make sure that we are spiraling proofs into every unit because we want you to be ready to write your own proofs when we get to that unit. When you are doing a proof, you always start with the given and you end with the proof. Start and end, always. Start and end. Now what we're trying to do here is what your textbook does is that if you notice on here, it says the same side interior angles is a postulate, and then all the rest of them, alternate interior corresponding, all the rest of them are theorems. And the reason that it does that is it is assuming the same side interior angle one, we're assuming it's true. You just have to pick one. And it happened to be the chosen one for your textbook. But we're assuming that that one is true, that those are supplementary. Then we're using that one to prove all the other theorems are true. So we call this one a postulate because we're not proving it, we're assuming it. Then we use that to prove all the other ones. Something that can be proved is a theorem. You're not going to be tested on which one's a postulate and which one's a theorem. I just wanted you to kind of understand why we're doing this. Okay, so how do you write a proof? First, you state, these are my statements. First, you state the given, and your reason is always given. That's easy. Okay, next you kind of move on to, what am I trying to do? I'm trying to prove that 3 is equal to 5. I'm trying to prove that alternate interior angles are congruent. They gave us all the statements, so all we're going to worry about for this proof are the reasons. Okay, 3 and 6 are supplementary. Remember what I told you? We're going to assume that one of them is just true, and that's going to prove all the other ones. So 3 and 6 are supplementary. That is the same side interior angle postulate. And it is on this piece of paper. Cool. All right. Now we know they're supplementary. We've established that. Now I want to say that their measures add up to equal 180. What allows me to say that supplementary angles add up to 180? Definition of? Yes, you're so good. Supplementary. Good. Now I've said they add up to 180. Now I want to say that they are a linear pair. Oh, that's a new one. Nope, sorry. We're starting. So this is the end of one logic statement. Now I'm going to move on to a new pair of angles, 5 and 6. To say what I want to say about 5 and 6, I have to first say that they're a linear pair. I have to say the vocab word. Why are they a linear pair? They're a linear pair because the definition of what a linear pair is. Now that I know they're a linear pair, now I want to say that they're supplementary. If two angles form a linear pair, then they are supplementary. That's a theorem. That's the linear pair theorem, the LPT. Okay, now that I said they're supplementary, oh, this looks familiar. Look at this. From here to here and from here to here. I'm doing the same thing I've already done in my proof with a new set of angles. Now I want to say 5 and 6 add up to 180, and it's going to be the same reason as before. Definition of supplementary. You can use something twice in a proof. Okay, so now I have that 3 and 6 add up to 180, and I have that 5 and 6 add up to 180. So do you agree if 3 and 6 add up to 180, and if 5 and 6 add up to 180, then this one should equal this one, because 180 equals 180. That's what we're trying to say from here to here. So on this one, I'm open. You can use transitive property. Remember that weird one from last time? Or if you put substitution, I substituted, that wouldn't bother me. Because that transitive property is kind of weird and it's hard to remember. But you sure can remember, oh, instead of 180, I just substituted 5 and 6 right here. I'm okay with either one of those. All right, if I were solving and I subtracted 6 from both sides, I would say that 3 is equal to 5 because I subtracted 6 from both sides. I really just wanted you to watch. If that was confusing to you, I get it. I am not going to quiz you over this. I am not going to test you over this yet. I just don't want us to get to the unit where you have to prove and you've never seen a proof before. I just want you to get used to the logic. So if all you did was watch, then that is okay. I am not asking you to do this yet. You're right, yet.